Imagine waking up one morning and discovering that they've decided to create a second sun here on Earth. Sounds like a script straight out of a science fiction book, right? And so it was that, in 1952, the world witnessed the first demonstration of what would come to be known as the fusion bomb on the remote atoll of Enewetak. The protagonist of this historic moment was Ivy Mike, a colossus of technology that, despite its enormity and lack of practicality, opened the world's eyes to the terrifying potential that nuclear fusion possessed. So what makes this day so special? What happened to turn an apparently ordinary date in the calendar into a historic moment that makes us question the limits of human ambition? The answer involves science, power, and a dose of daring that defies the imagination. On that date, we were on the verge of witnessing an experiment so audacious that it could well alter the very essence of our planet. Now, keep that curiosity burning, because we're only just beginning to unravel this fascinating episode in our history. Up there, 6,524 miles above the ground, a Tupolev Tu-95 airplane carried with it not only the responsibility, but the power to change the world as we knew it. And indeed, that day has gone down in history as the day we created a second sun on Earth. But how did we get there? The history of nuclear bombs, including the notorious hydrogen bomb, is indeed a tale full of fascination and a pinch of terror. It transports us to an era marked by a striking paradox. While humanity was making monumental leaps in the field of science, exploring the unknown and expanding the frontiers of knowledge, it was simultaneously honing its skills in a much darker art, that of destruction. Just imagine, scientists all over the world, in their laboratories full of test tubes and complex equations, were not only dreaming, but working hard to master the power of the atomic nucleus, that same power that gives life to the sun and the stars. The conception of the hydrogen bomb was no mere accident, but a calculated goal, pursued with the same intensity as we seek cures for diseases or space exploration. Nuclear fusion, that stellar process that bathes us in light and heat every day, has come to be seen not just as a wonder of nature, but as a source of almost divine power, capable of releasing energies beyond human comprehension. And the most intriguing thing is that this journey towards mastering fusion began almost simultaneously with the development of the first nuclear bombs, putting humanity in a race against time and against itself to achieve a power hitherto unimaginable. Which leads us to reflect, how can a species capable of such scientific genius also flirt so dangerously with its own annihilation? This is the dilemma that permeates the history of nuclear bombs, a constant reminder of the razor's edge on which we walk when it comes to the sheer power unleashed by the atom. Did you ever stop to think that, way back in the early 1940s, while the world was immersed in the turmoil of war, two physics geniuses, Enrico Fermi and Edward Teller, were at work, devising nothing less than a nuclear fusion bomb? That's right. At a time when the idea of a nuclear explosion was more fiction than reality, these visionaries were already envisioning a future where the power of the stars could be summoned here on Earth. Fascinating, don't you think? And while the conflicts intensified, casting increasingly dense shadows over the future of humanity, entire nations launched themselves into an unbridled race for nuclear knowledge. It was a veritable marathon of knowledge, with the clock ticking down, where the prize was an undeniable advantage on the battlefield. Among all these efforts, the Manhattan Project stands out, a U.S. initiative that would come to be known as one of the most successful and feared scientific endeavors in history. But what makes the hydrogen bomb such an extraordinary and feared artifact? Well, for starters, let's talk about Edward Teller, one of the brilliant scientists behind this innovation that would change the course of history. Imagine spending days and nights, years on end, immersed in calculations, theories, and experiments, all to understand and master nuclear fusion. This was Teller's monumental challenge, to unlock the secrets of a process that was infinitely more complex and less understood than nuclear fission, which was already the basis of the first atomic bombs and had been widely studied until then. Fusion, on the other hand, was an unknown, a sleeping giant that promised to unleash unprecedented powers. And here, my friends, we dive headfirst into two concepts that are true pillars of the nuclear universe: fission and fusion. In the fission process, we break a heavy atom, such as our well-known uranium-235, into smaller pieces, a reaction that releases gigantic energy, capable of shaking the most solid structures. Fusion, on the other hand, is true cosmic alchemy. We take light atoms, such as hydrogen, and fuse them to form a heavier atom, such as helium, in a process that releases amounts of energy that make fission look like child's play. But how can we replicate our sun's stellar furnace here on our modest Earth? The answer, my friends, came in the form of an idea as brilliant as it was audacious, courtesy of the genius mind of Teller and his collaborator, Stanislaw Ulam. They proposed a solution that sounds like something out of a science fiction novel. Why not start nuclear fusion with a little push from a fission bomb? This concept, which would become known as the Teller-Ulam design, was the master key that unlocked the door to modern fusion bombs. In other words, they combined the brute force of nuclear fission with the sheer power of fusion to create something totally new. A device capable of unleashing unparalleled destructive force. And so Teller-Ulam's design not only established itself as the basis for all the hydrogen bombs that followed, but also marked the beginning of a new era in human history, one in which the power to recreate, on a small scale, the energy of the sun itself was within our grasp. Yes, but believe it or not, this scenario has almost come true. Let me take you on a journey back in time to October 30th, 1961, to the remote Novaya Zemlya archipelago in the icy north of Russia. That day, which at first glance might be marked by its triviality, is about to be revealed as one of the most extraordinary and potentially terrifying in human history. But my friends, it was only a preview of what was to come. 9 years later, in 1961, the Soviet Union decided not only to enter history, but to rewrite it. The Tsar Bomb, as it was nicknamed, was not just another bomb. It was a show of force, an assertion of power. With an energy potential 100 times greater than the bombs dropped on Hiroshima and Nagasaki, this giant showed the world the true meaning of destructive power. The Tsar Bomb saga and the frantic arms race that followed are a powerful reminder of the duality of technological innovation. On the one hand, we reach incredible milestones, expand our horizons, and challenge the limits of what is possible. On the other, we are faced with the grim specter of the consequences of these innovations, the palpable possibility of mass annihilation. Today, many of us live under the illusion that the nuclear threat is a ghost of the past, a concern of a bygone era. However, this threat has not disappeared. It has merely receded into the shadows, waiting. Understanding the history of these nuclear weapons, delving into the intricacies of how they work, is not just a matter of intellectual curiosity. It is a necessity. By understanding where we've been, what paths we've taken to get here, we can perhaps pave the way for a different future. A future in which the measure of human success is not calculated in megatons, but in our ability to coexist, to build bridges rather than destroy them. I thank you for accompanying me on this exploration of our technological and nuclear past. Together, perhaps we can dream of a more peaceful tomorrow. Until our next meeting on this journey of discovery,